Um, I believe this picture is familiar to a lot of people. Um, it shows the speed distribution of the stellar object in the Milky Way. I started here, but for a distance bigger than 10 kpcs, the speed of the stellar object is moving faster than what Newton's law predicts. Newton's law predicts according to this red line, but the speed distribution is according to the blue line. And also, in an area between 1 kpcs to about 8 kpcs, the observed speed it is slower than Newton's law predicted. This area, okay, this entire picture is for the Milky Way distribution, but I shaded in two different colors. The yellow shaded color is corresponding to this area. The green shaded area is corresponding to about this area. There are two lines. I will explain what these two lines later. Okay, because that speed distribution of those stellar objects is different from what Newton's predicted. Some people think Newton's law is not working, at least working with discrepancy. They try to propose two major theories for the repair. The first repair is proposing dark matter, and to give a legitimacy to the existence of dark matter, they tried very hard to relate it to relativity. But as we said in this morning, relativity cannot prove or warrant anything. So dark matter should not have a chance to exist, in my opinion. Maybe the other theory can prove dark matter exists, but at least at my knowledge, I don't see any other theory can provide the support for dark matter. And then the second repair for the Newton's law is to modify Newton's gravitational law. But I believe many of you are professors or teachers, and there's one principle I don't think you will allow to happen. If a student taking a test, say the teacher, the law or rule you teach me could not help me to get the right answer, the law should be modified. The rule should be modified. I don't think you will permit it. Okay. Now, the reason, in my opinion, why those stellar objects moving at different speed from what Newton's law predict is because there's one key thing. Newton's law must apply in the consideration that the gravity body is seen as a point mass. The shape of the mass cannot be stepped in the picture for consideration. If in the close vicinity of the gravity body, the shape is obvious, we cannot just simply use the same law as if there's a point mass there. I try to give example here. Okay, this is a bar. This is a point mass. So from now on, with this kind of this picture, it's a point mass here, and our material body moving about here. The gravitational force between them, I would call it normal force. Just like a situation like this, and I am not going to. I don't mean that only this force is normal, but most of the time we apply Newton's law in that situation. That's why I call it normal force. If this mass, the gravity body, becomes a bar with the same quantity of a mass, this material body A will have higher gravitational force from this bar. I will call this effect that body A receive a higher gravitational force here as the on-axis effect. Now, the previous body A is placed directly below this bar. And with differential calculation, I think all of you are more than capable of doing that, so I'm not going to give detail. I just point out the end result. The end result is this body will receive a slightly less force than the normal force here. In the next slide, I will add one more bar there. That new bar is identical to this one. Over here, this body A receive a lot less gravitational force than the normal force here. Although this point mass has exactly the same mass as this bar. But over here, the bar shape must be given consideration. Over here is only a point mass. With the same bar, when this body A move from here to here, he moved through two regions. Over here is the on-X effect, very strong. If the tangential speed allows it to resist the gravitational pull from the bar and able to continue to move over here, it will receive a much weaker gravitational force over here. And then the same angular momentum received from here, but encounter a lot less weaker gravitational pull from the bar. This body A will fly away with higher than normal speed, that's for sure. I will call the body A here, is very hard.
Oh, is it running out of battery?
It seems so.
Oh, okay. Give it to me. I'll change the screen. If somebody has a I have batteries.
Okay.
I have mine.
It seems so. Let me see if I got battery.
Oh, wait. He's got one.
Mine might not work for the lecture because
There
it's
you
a
go.
green
Oh,
light.
great.
instead of a-
Thank you.
There you go.
I got it.
Okay.
Let me turn that on.
Thank you very much. When the body A here receive a less gravitational force, I will call this effect on the A as off-axis effect. So we can say that the same body A should have different speed in these two locations, from E to F. And then,
You want me to change it?
okay, yeah, thank you.
Okay.
The other way, the next slide, please.
The right button. Next advance. I'm sorry?
Okay.
For next slide? Oh, I'm sorry.
No,
Okay.
no.
I went the wrong way. Okay. Is that right?
Yeah. Oh, Previous one, please. Yeah, thank you. Because
Oops, sorry.
that's okay.
Go ahead, sorry.
The, okay, let me do it. I'm like,
I'm okay, that was my fault.
okay,
Okay, go ahead. Just say next for,
okay.
when you're ready.
Okay, now instead of comparing the tangential speed here with k and d, I will normalize them with one letter, n, by making k equal to nd, where n is not 0. And from the comparison, we know that the tangential speed for this body A to survive the gravitational pull here is forever bigger than here. Next, please. Okay, now we have two locations, E and F. If E can be explained with dark matter, can we use the same dark matter to explain why that the body A has to fly with higher speed at the location F, or vice versa? If we happen to think the body A can survive with a certain speed, a higher speed at location F, we will go back to say, the wonder why E did not, body A did not get gravitationally sucked in by the bar at location E. We can explain these two different situations with the same dark matter. Okay, in this situation, I use two bars perpendicularly to each other, and at this location, the gravitational force experienced by A is almost like the normal force here. And the gravitational force resulting in the tangential speed here is almost the same as the normal force. Next, please. However, at the tip of the cross, things is quite different. Okay? And over here, this body A must have a higher speed to survive the pull, because the gravitational pull here, it is stronger than over here, although the distance are the same. Next slide, please. Oh, sorry, previous. Thank you. So, when this body A fly with tangential speed and survive the pull, when it enters to this region, it definitely with higher speed, because the gravitational pull along this line is weaker. So body A may tend to fly away from the cross at this point. However, when it continues to move, it will enter a region that on X effect, gradually getting stronger. And then the gravitational force is weaker here, and the speed of A will speed up again, and then slow, and then high, and then low. In other words, if this body A happen to have a close orbit around this cross, on its orbit, its speed cannot be a constant one, but higher, lower, higher, lower. Next, please. If several objects line up on this line, it's easy for us to visualize that body C should have a higher tangential speed than body B. And then body B will have a higher tangential speed than A. Next slide, please. No, back, I think. Okay. Okay, thank
Yeah,
you.
it was a different one, it's the same picture.
Okay. Then next one, please. Okay, I list some figure for comparison. A, I make it the constant here, all the same, but Q is different. Over here, Q is this distance. It's almost like A, just a little bigger. But over here, we increase it. Yeah. So at the tip of the cross, we end up some comparison like this. This is the normal speed, okay? As if the cross has shrunk into the point mass. But here, we give the consideration of the shape of the cross. And then ends up that at this location, the shape of the cross will give the gravitational force 2.4 times higher than the normal force. If Q over A is 1.1 time, and then the gravitational force at the tip is 1.81 higher than the normal force. Even down to 2, it means that Q in coming down here at tangential speed still has to be 1.06 higher than the normal speed. It is only until after the magnitude of 5, and then the tangential speed of the shape of the cross can be compatible to a normal force. With this ratio 5 times, with respect to the Milky Way radius, we are talking about 80 80 kpcs. That is there's many more light year away. Right now, the Magellanic Cloud is about 160,000 light years away from us. It's about 3 times of the radius of the Milky Way. Next, please. Yeah. Here, Magellanic Cloud is about 3 times of the radius of the Milky Way radius. Next, please. Okay. We see the picture before. Body C has higher speed. Body A has the lowest speed. In case this arm consists of loose material, we can visualize a picture like this. The closer to the center of the cross, the higher the linear speed or the material body will be. If all arms is considered loose material, and then we can come to a picture like this. However, when we really go into the center of the cross, the picture is different. This cross rapidly spinning into just appear blurry. At this point, people may ask how this cross appeared at the beginning. And I think this cross will not be purposely organized by anyone, but nature can easily establish a bar, not a cross, a bar. Okay? The cross is only for illustration, but a bar is naturally formed by the nature. However, to get to that picture, we have to have some idea completely dissociated from the idea of a Big Bang. For example, our Milky Way, the material, the initial material, is randomly tossed together. Next slide, please. When it's randomly tossed together, there's some material, maybe higher in some area, the thinner in another area. And the evidence showing that the material forming of Milky Way are randomly tossed together, nowadays we still have this evidence. For example, Andromeda galaxy is seen that approaching us. There's nothing object, an argument. In the old time, there may be some other material joining their location to form the Milky Way too. And it's also said that some globular clusters are still contributing to our galaxy nowadays. And one more evidence is that the Magellanic Cloud, considered as a satellite galaxy of the Milky Way, but in my view, it's not a satellite. However, trading on what it has been coming and going, it is the Magellanic Cloud did have a journey joining us. However, because of some distance miss, it is unable to stay as a satellite or even joining the Milky Way galaxy. It is in a way moving away. Okay, those material are joining together at different speed, possessing different nature, and from different birthplace and different epoch. Next, please. Okay, when material randomly tossed together, there are two things to be guaranteed. Number one is that momentum cannot be exactly cancelled out. There will be some residual momentum, linear or angular. Angular momentum determines how the final material gathering spin. And the linear residual momentum will determine how it will translate moving with respect to other object or other galaxy, other celestial body. The next thing guaranteed is the inhomogeneity of material distribution. When something like this is spinning, some heavier material or some higher concentration grouping will be swung out by centrifugal force, gradually moving out, gradually moving out. However, gravitational force at the same time will line them up across the mass center of the material gathering. This will give them a chance to form a very primitive bar on this line. Because it is a bar, it has on-X effect at both ends. And material flying by will be recruited by this bar. But if material is recruited on this bar, it will beef up its gravitation force and enable to attract more force to join it. And then this bar gradually becomes gravitational predator and beef up itself. Next slide, please. Okay. I just explained it. Sorry. Okay. When the bar forms itself and rotating, however, there's some material further away from the center of the bar could not have enough angular momentum and not enough angular speed to keep up with the rotation of the bar. However, at this area, the on-axis effect is strong. It will grab this body A to rotate together. And then further away, B is lagging even more behind. However, the on-axis effect of the bar and the A's gravitational force together grab B to move together. With the same reason, C is also grabbed together. So gradually, we will see a ribbon of material flowing out of this bar. At the other end of this bar, you can expect the same thing happening. There is another ribbon of material falling out. But nevertheless, some material body really have that angular momentum too weak, unable to keep up with the rest. And then there are two fates waiting for this body D. It will either get sucked in by the bar if the angular momentum is really so weak. However, it may also have the angular momentum at the right value, and it can resist the gravitational bar or gravitational pull of the bar. But in this area, the off-axis effect, it is dominated. The gravitational pull is weaker. So this material with a weaker angular momentum still survive the pull from the bar. And so long as its angular speed can synchronize well with the rotation of the bar, it will stay there. This is the reason why there's a 3 kpc arm near the Milky Way. Next, please. Okay, on this picture, we will see this far 3 kpc arm, and then there 3 kpc arm. It is formed by material as pointed out by the D. And at both ends of the bar, this galactic bar, the on-axis effect is stronger. That's why we spot higher material concentration at the end of this bar. And also, we have two major spiral arms. That is what we see with the material A, B, C in the previous picture. We also see that there are many other smaller spiral arms, and they are formed with some gravitational force or angular speed in the value in between. All those are not stable organization in the long run. In a very slow processing, they will reorganize them again. And some will fly further away, some will move backwards, that kind of thing. Next, please. Okay, on the previous picture, the same Milky Way picture, I shaded them in two different colors. I explained this before. Along this yellow line is a strong on-axis effect. On this purple line, it is where the off-axis effect dominates. If we see this arm over here, this material may be flowing away, but it may be flying away. However, because of some proper speed, it stays there. Without the material AA over here, the off-axis effect very dominating. This material BB would have flown long ago. What else should I say? Okay. The solar system is about here. This is very interesting to me because angular-wise, in the angular area, it is between the strongest on-axis effect and strongest off-axis effect. It is about midway in between. And to me, it can be said it is a coincidence or not. However, because we live here, it's not that coincident to me. Okay? We heard a lot of talking about the alien from other planets, from other systems. However, even given credit to evolution, it means that ecological system, the evolution history on those areas must be identically the same as the solar system. And then we can result in a creature looking so, with so much closeness to us. Even over here, let me see, previous picture please. Okay, the solar system here. Even if we look at across on a symmetrical area, over here, we don't see material in a similar location over here. Okay? And if we count it from the center, and then we see 1, 2, 3, 4, and then we are at the 5th layer of the spiral arms. By counting over here, we found the method is 1, 2, 3, 1 layer missed. It means that in case there's some special radiation from the galactic ball, we are luckily get one more shield from those minor spiral arms. And earlier, David mentioned the tectonic plate. I believe tectonic plate movement on the Earth is deeply related to evolution. And I'm not going to go more detail to that. However, one thing I would like to see, people in the subcontinent, I mean Pakistan and India, people seems have 3 traits from 3 major races: Asian, Caucasian, and black people. And they have 3. It seems they all have those 3 traits. The reason is, in the long time ago, the India land is next to Africa. I'm not surprised that the African people, in those people, we all are not people anyway, but we call animal or living being. Those living beings are the indigenous from Africa. But gradually, when the subcontinent moved up to mid-Asia, and some some primitive people from Asia joining that continent. Some people from Europe also joined the continent. Gradually, the subcontinent is really a gene pool of all the races. That's how I see. However, after the subcontinent really connected with Asia, the traffic route between all the people are completely nearly stopped. That's why people in this separate location keep their own particular trait. Okay. Next, please. Next again, please. Okay. I just want to bring some picture to show that two spiral arms are a dominant feature for rotating galaxy. Some of them are more obvious, some of them are not that yet. But for those not that obvious rotating arms, in the future they will form the two arms. Next, please. Okay, over here I would like to say that the Magellanic Cloud should not be a satellite for the Milky Way. The Milky Way can be considered consider some bars which lay side by side and also lay within the galactic plane. When the Magellanic Cloud, like this A, move at this plane, it receives the dominant on-X effect from each of these bars. Although this bar on the side, the effect is weaker, but the principle is the same. But when the Magellanic Cloud moves down here, it will encounter much weaker gravitational force. The off-axis effect dominate here. So if the Magellanic Cloud can survive here, when it moves here over here, it has definitely much excessive angular momentum. And excessive angular momentum, but a weaker gravitational pull, it can only end up flying away. It cannot come back. Next slide, please. Okay, this picture I just try to tell how possible that A can have an orbit with respect to this, because it takes too much good English to explain. I cannot explain it here. Okay, so I just skip to the next. No more. Just I want to concentrate on this topic. Okay, the large Magellanic Cloud has a speed 378 kilometers per second. And the small cloud has a 302 kilometers per second. If what Big Bang says is true, the universe has 13.5 billion years. With this speed, we can trace back the birthplace of the Magellanic Cloud to this distance away from the Milky Way. Could this distance be the birthplace of the Milky Way? The Magellanic Cloud? Or if we are the creature of living in the Magellanic Cloud, can we say that the birthplace is the birthplace of Milky Way is 17 billion light years away from the Magellanic Cloud? Either way, we can say that if if the Big Bang is true, if you say that the diameter of the singularity can be as big as 17 billion light years across. But of course, with this data, we have assumed that the Magellanic Cloud has been traveling along a straight line all the time, and the speed is keep constant all the time too. But I believe this picture alone would cast skepticism to Big Bang already. Okay, that's all I say. Thank you very much. Yes, sir.
I have studied the structure of a lot of galaxies, and I find that they have chiral symmetry. And that symmetry is expressed in the number of arms. And the chiral symmetry requires they have 3, 5, 7, 11, 13 arms. And so is there anything in this model that you're presenting that can explain that symmetry?
I didn't think of it. However, I believe when they are assuming the arms, they are in the processing of forming the final two arms.
Uh-huh.
That's how I think. Yeah. I believe at the beginning, there can be as many as arms as there can be because the final dominant arm has not been in shape yet. Yeah, the central bar. Yeah, it's not in shape. When the bar, the dominated predator bar come into shape, it has only two ends, and then it will result in two spiral arms.
There is an explanation for many of these things using what's called modified Newtonian dynamics, which is able to predict the size of the and the velocity of the outer arms. It's able to predict the luminosity. It's able to predict a number of characteristics of the spiral galaxies. Can you predict with your approach something equivalent to modified Newtonian dynamics?
At this point, I don't know how to modify Newtonian dynamics because I still, in the old school, I think Newton's theory on the mechanics, and I don't see any room to modify it.
Well, in my work, I find that I was able to drive both the force of gravity and the force of inertia from electrodynamics, a more complete version of electrodynamics. And I get a second term in the gravity formula and a second term in the inertial formula, and that enables me to obtain a modified Newtonian dynamics. In other words, Newtonian dynamics is only part of the whole expression.
Let me put it that way. With Newton's three laws and gravitational law, you can predict the movement of a material body around the gravity body. With three trajectories. One is hyperbola. Another one is parabola. The third one is the most phenomenal. It's a closed ellipse, yeah, a closed orbit. Whoever tried to modify Newton's law, if his law can result in an elliptical orbit, I believe he has been true. But so far, such as general relativity, when it claims how accurate it is compared to Newton's law, I would challenge it. Whoever say that with one phenomenon, can you use your law to describe an elliptical orbit around a gravity body? If you cannot, I think you have to have a second look about the theory.
Well,
Yeah, yes.
Could you repeat the previous part about Newton theory and possibility to prove it wrong?
I did not say I prove Newton's gravitational law wrong. But I said,
But said if somebody would come up with something,
oh, if somebody can come up with something to end up modifying Newton's law, I said he may be getting the truth if he can use his theory to derive an equation describing a closed orbit or an elliptical orbit around a gravity body. I know that
it's, I mean, in alternative fashion compared to the Newton law, right? I mean,
okay.
by doing that in different way than indeed.
Okay. Let me repeat again.
Because you know,
I can explain, I know what he's saying. What he's saying,
It is currently taken, actually, read on upon that Newtonian theory with central force proportional to 1 over r squared solves the problem. It's the elliptical orbit to 1 over r squared.
I'm not going to go into medical detail. I only say that.
Why wouldn't be you satisfied with that approach, that commonly accepted approach?
no, I think what he's saying is this. He's saying the same thing that we say, which is Newton's law you can get everything from it, even the things that we think that aren't Newton's. But he's saying that if you have a different law other than Newton, you better be able to do these orbits as well. Because what he's saying is, he doesn't think that you can take Newton's law, modify it, and still get what Newton has. You're going to get screwy answers.
Yeah, how about
That's
some-
what he's saying.
How about some totally alternative theory?
No, well, I'm not, I understand, but that was his point.
Yeah.
He wasn't saying he did it different or something different is wrong. He's just saying it better be able to do the regular orbits as well.
But would that be bringing any advantage?
Advantage about.
My point is why you would be needing it.
Okay.
What is your reason for it?
Okay, the reason I believe is that somebody tried to put up some theory in place of Newton's law, but I just try to defend Newton's law is irreplaceable in my understanding. Yeah, it is still a useful law. Relativity is gone. Special relativity is gone.
So,
General
just
relativity is gone.
One brief. So, does it mean that you mean that if there would be some other theory that is producing what the Newton theory is producing, would your theory then be?
All my theory are based.
Would it be still fine? I mean,
All my theory, so-called theory, are still based on Newton's law. I did not create anything.
So if-
I only ask people, if you consider modifying Newton's law, please take into consideration the shape of the gravity body when the moving object is in a close vicinity of a gravity body.
and you mean whatever theory one takes should consider something what you did.
Yeah, that's what I did. Yeah, and I don't think dark matter or Einstein's relativity can explain any of those. Yes, yes.
Can I? My father did this a while back, and it was you're the second person I've seen apply Newton's laws to non-point masses. My father's been doing calculations for 10 years on all kinds of shapes. So basically, when I saw what you were doing, we came up with the exact same solution, not so specific, but with Newton's laws. We use Newton's laws to show you don't need dark matter. Why? Because people aren't taking into account the geometry of mass. My father's, we used a field of G1 particles to create this. So tonight we'll show the same thing. You have a disk, the G1 particles going here. You have different forces. So my father spends time to describe all the paths through a geometry. And what kinds of shapes have you done? You've done
Spheres, ellipses, cylinders, box, cylinder, rectangles, boxes.
So you're the second person I've seen actually apply. When you started doing this, I said, no, there's no way. Someone's actually doing it. So to summarize what he's doing, he's saying, if you apply Newton's law, like my father is applying, and include geometry, because if you have this big thing, it's going to be doing all kinds of weird things. If we calculate it as a point, that's not what's going to happen. But we never do that. And because we don't do that, we get all these things that we think are anomalies, which is, let's invent dark matter. Heck, my equation will never be wrong. I found God's equation, it can't be wrong. But what's happening is he's applying he applied Newton's the same way
I don't
to,
apply Newton. I have my own equation.
No,
but
no.
It's Newtonian-like.
force, all of your things are F equals ma, right? Right?
That's a basic formula you gotta use. All of our mechanics fall apart without that. I don't use G times M over R squared. I do not use R squared.
Yeah, you were using Newton's actual formulas?
Exact formula.
His is more primitive. He actually goes back to G, that gravity can actually be done with F equals ma. And but it's the same idea. You're just using the more general equation where he's actually doing all the small forces as particles.
Okay.
But you did apply. You're right. I'm sorry. You're right. So he only uses F equals ma, and he
Yes,
still
sir.
gets the same thing. But it's Newton.
I've come across two very interesting explanations for the stability of the spiral arms. One is a gravitational explanation. I found a website. Somebody 10 or 20 years ago did a simulation where they put all the little stars in the spiral arms, and they show that they attract each other, that the spiral arms are stable, and that the speed, there's no dark matter, and that the speed on the outer, the speed is constant, the angular speed is constant, et cetera, et cetera. And of course, the other common explanation you'll find for these, if you're in the electric universe area, if you apply magnetic fields across the galactic disk, you can explain the stability as well. But the interesting thing is there's a simulation that was done by Peratt that shows how the galaxy actually forms they of course won't do the electric universe people don't want to throw gravity into anything. So there's one simulation that shows how an electromagnetic effect can produce the spiral arms as well. If you're interested, I have the references.
Okay. Yes, sir.
So now, is the assumption of the Newton's equations here that the speed of gravity, the force speed of gravity is infinitely fast, right?
I don't touch the subject yet.
Right. Well, the general theories going on with people. Even the greatest cosmologists said we don't understand how to take the gravity waves, which they say you might go at speed.
I believe that
They would be big nets, and they would go around multiple times around, so nobody's touched it. It's a very complex.
I believe that do exist the gravity wave, and it is related to some material or medium that allows light to propagate. Yeah, and for the material tossing together, I would like to propose one model of the universe. And if I'm wrong, point me out, please. I would like to say that the universe is infinitely old, no age, infinitely large, no distance, no radius, except what we see as the universe today is only its visible portion. It is wrapped by infinite like large, invisible portion. However, that visible portion is expanding because it is corroding the invisible portion and convert its idle matter into burning matter. And that's why we see stars burning at a remote distance and moving. But it will involve more illustration on that. However, one thing, and the Big Bang said that time and space are created, accompanied with the Big Bang explosion. But to me, it's false. Time's always there, and the space dimension are always there. No, nothing can create it because the universe is infinite. And if somebody can say that no, that the universe is by itself is expanding, I would like to ask how he will propose there is another portion, invisible portion, wrapping around whatever we have seen today. Okay, thank you very much.